All right, in this tutorial, we're going to simplify radical expressions that are involving fractions. Now, it is a little bit different when it comes to radicals over both your numerator and your denominator. The more important thing is dealing with your denominator, and we're going to focus on how that little wrinkle gets worked in the second example, which I've switched in your tutorial notes from the you try example at the second one. So the second problem is going to be switched in order for you to practice this new simplifying of your denominators. You'll see in a bit. The first one, however, let's go ahead and separate our numerator and our denominator. Then we can separate our denominator even more so into the numbers and the variables. That is an 8. Now, simplifying our 7 for the numerator. The 7 is a perfect square, or it's not a perfect square, it's a prime number, which means there are no perfect squares, and there's no way that we can use only the factors of 1 and 7 to reduce this numerator. So we're going to leave that square root of 7 simply like that in our final answer, unless there's something that we can cancel with it later. On the denominator, the square root of 9 is a perfect square, which is going to give us a 3. And then we need to think of the square root of f to the 8th, taking 8 f's in groups of 2 out from underneath the radical. So taking 8 out in groups of 2, 8 divided by 2 is 4. So we're going to be left with 3f to the 4th power. Numerator stays the same. Denominator, 3f to the 4th. There's nothing that we can simplify between the top and the bottom. So we're going to leave our solution just like that. The second example, so we have a couple different ways that I'm going to show you how to do this. The first one is going to be kind of using an intuitive approach of simplifying before you're separating into the tops and the bottoms. Your square root of 10 over 18, this whole fraction can be reduced if you divide by 2 from the top and the bottom. You're going to be left with the square root of 5 over the square root of 9. 9 is a perfect square, so you have the square root of 5 over 3. And again, 5 is prime, so you cannot be left with that. The other way is to use what's called rationalize the denominator. So let's imagine a scenario where you are not able to reduce your fraction at the very beginning of the problem, and we need to separate our numerators and our denominators right from the beginning and factor each of those numbers individually. So 10, the only factors of 10 are 2 and 5, 1 and 10. Neither of those pairings have perfect squares, so we cannot simplify using that one. 18, however, does. We've got 1 and 18, 2 and 9, 3 and 6. 9 is our perfect square, so we're going to use the factor pair of 2 and 9 to help reduce this. So we've got the square root of 10 still on top. On bottom, we have the square root of 9 times the square root of 2. The square root of 9 becomes 3. And we are left with the square root of 2. Now notice how you have a radical in our denominator. That is not okay. That is not a rational number. It's irrational. A lot of test formats in ACT do not allow you to have radicals in your denominator. One of the sayings that you may hear is don't go around with your radical down. And that just means don't put a fraction as your solution or as your simplified expression in the denominator. So the way that you rationalize it or you get rid of your radical in the denominator is to multiply by what's called the conjugate. Now the conjugate is just you look at what's in the denominator right now and you're going to multiply that thing times what the denominator is. So we're going to multiply in our denominator, we're going to multiply times the square root of 2 on top and the square root of 2 on bottom. So we're left with the square root of 20. 10 times 2 is 20. Square root of 2 times square root of 2 is the square root of 4, which, funny enough, is a perfect square, and that's the whole reason as to why we multiply by the conjugate, is to get the square root of 20 over 3 times 2, which is 6. Then from here, we're going to simplify with our factors of 20. Perfect square factors are 4 and 5, so the square root of 4 times the square root of 5 over 6. The square root of 4, I'm going to move all the way up to the top. The square root of 4 is 2. We have the square root of 5 over 6, and then 2 goes into 6 3 times with a 1 left over, which, funny enough, is the exact same solution that we came up with our intuitive approach. So if you do end up with a radical in your denominator, you're going to multiply by the conjugate, which is whatever radical term is in your denominator, that's what you're going to multiply by. Just make sure that you're doing it to the top and to the bottom, because whenever you multiply times the top and the bottom, that gives you 1, and you're not changing the fraction itself.